All right, part 2. Number 16. Look at all these crazy numbers in here. This is kind of like, it's falling into the world of PEMDAS, where you guys have been trained to think, well, if I can add something inside parentheses, something crazy like that, you should. So that'd be 8x. But my point is, let's try to simplify this before we get crazy with this thing. So let's try to ignore this radical and simplify this. 3 would go into 297, 90, what would that be, 27? 97? Uh-oh, I'm doubting my mental math. Give me a second. Good thing I checked. Not 97, 99. And then, how do we reduce m to the 4th over m squared? Well, there's 2 ways you can do this. The way I taught it in class was, where's it warmer? Upstairs. By how many degrees? 2. What's the real algebra way of doing it? You take the m, this, minus the bottom one, and then you get the same thing. I like this technique. Where's it warmer? So that's m squared, and we'll do the same thing here. 5 and 1, where's it warmer? Upstairs by 4 degrees. Now we're not done, because we still have this crazy cubic root situation going on here, so it makes the problem pretty challenging. Okay, so it does say simplify, so we might be done, we might not be done. You're not sure. So we got to take a look at all of our perfect cubic roots. Starts with 1, but that one really doesn't help us. 2 to the 3rd is 8. 3 cubed is 27. 4 cubed is 64. Does this go into 99 evenly? No. Does this? No. I thought this might, but it doesn't. And then 64 doesn't either. So that 99 is trapped. This is less than this, so I can't break it down. It's stuck. Now this guy has got little work to do. So the cubic root of n to the 4th, what's the first number less than 4 that 3 goes into? 3. How many would be left? 1. What is this? Well, 3 divided by 3 is 1, so that's just n cubic roots of n. So this is the only thing that would be considered oil, and this is water, this is water. So the oil comes out, and everything else is trapped. M squared n. Strange answer, but there she is. Okay, cubic root of 3,000, cubic root of 3, and then that craziness. So we got to be creative, and here's our list of numbers that just might go in there, but there's more. So 8 doesn't go into 3,000, 27, 64. But if you remember, 10 times 10 times 10 is 1,000. So the cubic root of 1,000 is actually a perfect cubic root. So we're going to break that up, and the cubic root of 1,000 times the cubic root of 3, which is just 10 cubic root of 3. That's good for this one. This is going nowhere. I'll put a 1 in front of it just so we can help ourselves recognize like terms. And then we've got this 1,029 business. So if we went down our list and just investigated this, let me see if I can show you the calculator. And I'm going to take a guess. 1,029 divided by 27 seems like it has a chance. No. And then we just kind of keep going up the list here. And let me pause this a second. So rather than burn up the whole video listing all these, I just went down the list. 8, does that go in there? No. 27, no. Thought it might. 64, no. This was a no. This was a no. This, believe it or not, goes into 1,029 3 times. Now, this is 2, this is 3, this is 4, this is 5, this is 6. The cubic root of 343 is 7. So I end up with 7 cubic root of 3. So look, now I've got, this is a minus, let's not forget that, it'd be easy to forget. I got 11 cubic root of 3 minus 7, so I get 4 cubic root of 3. These are doozies. This one's a little bit easier, a lot easier. 45, 9 and 5. 180. Let's break that down. Let's be careful. I know 9 goes into that. I could go 9 and 20, but because this can be broken down, I must not have found the biggest one. And believe it or not, 36 goes in there 5 times. And then negative 720, again, we got to go through our big old list and try to find our biggest one. It makes our life easy. So I'm going to make a list and show you. Okay, so here's my list of all the possible perfect square roots that have a chance of going into 720. And after some experimentation, I divided by 81, thought it might be a chance because I thought 9s were common there. Didn't work. 36 worked, but I know that the square root of 20 is breakdownable, so I knew there was a bigger one, possibly. Well, for sure. And then, boom, 144. So we're going to break that down into the square root of 144 5 times. So this breaks down to 3 square root of 5, 6 square root of 5, 12 square root of 5. And so we get negative, well, we can add our negatives together, negative 18 square root of 5, and then 3 square root of 5, which would be a negative 15 square root of 5. Algebra 2, turning up the heat. Alright guys, multiply. So back to the basics. Your first thought might be FOIL, but then what we talked in class was this crazy word called conjugates. And if you notice they're conjugates, the outside and the inside will cancel, and you can just save some time. But because this is a review, I'm going to show my work and we'll talk about it. So let's say you didn't notice they were conjugates, and you just went to the FOIL machine. X times x, x squared, and then you'd get, and I know you can break that down, but I'm not going to yet, plus x squared of 8 minus x square root of 8, and then a negative times a positive is minus. If you square a square root, I mean literally the square root of 8 times the square root of 8, square root of 64, which is 8. That's why we use the jingle. If you square a square root, the roofs fly off. Notice the outside and the inside, they just cancel. That's why I didn't waste the time breaking those down. I knew they were going to cancel. What's left? X squared minus 8. Could have done it by just fooling. This guy, you've got some options, but I like the fact that that is just the square root of 36. Now I could have broke that down into square root of 4, square root of 3, but that'd be kind of extra work because this times this gives me a nice perfect square root, so I took it. Now this right here, I could go the square root of 72 and then break that down into 36 and 2. Now maybe you thought 9 and 8. That's not a bad thought. This is just a better thought. So that'd be plus 6 square root of 2. Now one thing I showed in class, square root of 12, square root of 6, I can break, I'm looking for a pair, so I take that square root of 12 maybe on this one. This is just another option. Make it the square root of 6 and the square root of 2. Now some of you are like, well, those aren't perfect square roots. Well, that's not the goal. I just want to get a pair of these. So that's times the square root of 6. These roots fly off, and I'd get 6 square root of 2. A whole different way of getting 6 square root of 2. So pick your poison, they say. Don't know if that's appropriate, but it is a phrase. All right, what is the reduced radical form of each expression? Well, you cannot find success by just going like this. It's not going to work. You guys have done a lot of these where all you had to do was go like this and it works. That's not going to work. It's good here, but then it attaches itself to there, so you're trying to get the radicals out of the denominator. So what's the goal? Well, the goal has to do with this, the fancy word conjugates. The only thing that works is by multiplying that denominator by the conjugate. So that'd be 3 plus the square root of 5. I got to do the same thing up here. So notice I'm going to distribute 9 plus 3 square root of 5. That's the top. in the bottom, I'm going to fool. 3 times 3 is 9. Negative times a positive is negative. Square root, the roots fly off. So I clean this up. 9 plus 3, square root of 5, all over 4. Now, just FYI, if you're on a standardized test, they might break that up into pieces, and don't panic if you see that. But this is the same as this. Now, question, can I cancel these? The answer is no, because they're not connected by multiplication. So, if you're in my class, add ends bad. Anyways, here's a what if. What if your answer ended up being like this? Could you be done now? No, because this reduces to 3. This reduces to 1 square root of 5. That's just a what if. Throw that in extra, no charge, free. Same problem here, kind of, sort of. Multiply by its conjugate. It's the only thing that works. So now we fool down here. 3 times 3 is 9. And a negative times a positive is negative. And then square root, the roots fly off. And here I distribute, negative 15, distribute it, oil and water, minus 5 square root of x. And we got the radical out of the basement, and nothing reduces. So we are done. That completes your quiz review. Reach out if you have questions.